Hello, POE people. I wanted to take a minute and talk about a piston, which is what this is, and talk about its mechanical advantage and how to find it. So this is a piston, and basically I wanted to talk about it because it's made of two simple machines. They're just connected in a way that might be hard to find compound or find the mechanical advantage if you don't think about it too easily. So you have a lever here, right? It's a straight piece of metal attached to a fulcrum down here. And then I have a wheel and axle. I know it looks like a gear, but it's not attached to anything. And then if you want to build it, all you need is a standoff here so it can get past the collar. Because otherwise, it would hit that if you didn't put a standoff. And then you just don't tighten it too tight down here. So it has room to rotate. If you tighten that too much, it'll just lock it in place. So basically this is a piston. I'm sure you've seen an old, train, train going down the track, right, there we go. All right, so how do you calculate IMA? Well, IMA, I'm a deer, right? It's pretty easy because it's still I'm a deer. What's nice is it's really easy to figure out distance resistance because before you get too crazy, look at this. This is as far back, if you think of my finger as the end point, this is as far back as it goes. And then if I push it through, it goes forward that far, and that's as far forward as it goes. So if I want to see how much the distance resistance, I imagine I'm spinning on this end. So I'm putting the effort in out here. So if I twist this machine, the effort is the turning of the wheel. The resistance is this thing being pushed forward. So it doesn't really want to go forward. So how far did it move forward? That's easy. You can just measure how far it was back here, all the way back, versus how far it is all the way forward. And if you think about it, it's just really the distance between these two places, where it is right now and that hole when it's all the way back. So you can just measure between this hole and this hole, and you can see how far, absolute far forward it goes and how far back it could go. So if I measure that distance, it looks like 2¼ inches, 2.25. X parts are measured kind of nicely. So there's the resistance. Now the effort also isn't bad, because if I'm twisting here, it's a half a turn on a wheel, a half a turn on a circle. Well, all that is 1/2 times circumference. So 1/2 times 2 pi r, and radius of this thing, I don't know, what's radius? Radius is 1 3/4. Well, what's diameter? Yeah, diameter is 3 inches. So 1.75 inches. I guess the 2 and the 1/2 cancel out, and we could calculate this thing as get a calculator. So it'll be pi times 1.75 equals, that's the top. I'm going to keep that number in my calculator, over 2.25 inches. So divided by 2.25, boom, and you get 2.44 as your IMA. So that's how you calculate a mechanical advantage on a piston. You're basically taking half of the circumference, because it goes from all the way back to all the way forward in half a spin. I didn't have to go all the way around. So that's half a spin around, and then my resistance is easy because I could just measure all the way back to all the way forward, and it's really the distance between these two. So there you go. That's pistons. If you want to use one in your machine, you're welcome to it. If not, don't worry about it. Now you'll learn something new. All right, talk to you later. Adios.